Yes, Rohina madam, we may start.
Yes, sir.
Kiran sir is there, no?
Yes,
Yeah,
he's
yeah.
There.
I hope I'm audible.
yes, you're audible, sir.
Yes, yes, yes.
So very good evening to everyone present. I, Dr. Ruhina Kazi, Head Electronics and Telecommunication Engineering Department, Anjuman College of Engineering and Technology, welcome you all to Atal Online 6-day Faculty Development Program titled Harnessing AI Technologies for Sustainable Rural Agriculture from 17th February to 22nd February 2025. Sponsored by AICT and organized by Department of Electronics and Telecommunication Engineering, Anjuman College of Engineering and Technology. So today we are on the fifth session for this development program, and the session will be conducted by Mr. Kiran Hivarkar, sir. Mr. Kiran Hivarkar, he is a he is a graduate in computer science engineering from PIT Nagpur, and he has done his post graduation from in CSE from VIT Vellore. He is currently having an experience of 10 years in distributed systems, currently working with as a software developer in NetApp Bangalore. His work majorly involves working on file systems and its auditing, having an experience in creating distributed low latency, high throughput pipelines. He has taken up multiple performances enhancement tasks across all aspects of system. His areas of interest include operating systems, networking, distributed computing, and AI. I welcome you, sir.
Thank you.
I,
Thank
requ-
you.
I now request sir to kindly continue with his session.
Sure. I'll share my PPT.
Sure, sir.
Is it visible?
Yes, sir, it is visible.
Okay. Yeah. Yeah. First of all, it's an honor to be here, right? And to share my insight with such knowledgeable audience. Special thanks to Dr. Nasruddin sir and Dr. Rashmi Bade for providing me this opportunity. So today I'll be sharing my insights on IoT and how it is helping smart precision agriculture to move India from traditional agriculture to more data-driven agriculture and process. Across this session, right, I'll start with some discussion around the today's agriculture landscape, how agriculture is not data driven. When we say data driven, what data needs to be monitored or collected with respect to agriculture. Then we'll discuss more about smart and precision farming, how it is enabling the data driven process in agriculture. Then we'll also discuss in depth on IoT, how it has become the fundamental or the backbone of precision farming. We'll deep dive into its architecture and the components involved. Further, we'll explore how analytics, ML, and AI are helping in precision farming. I have also included a case study of Tamil Nadu government and how it was able to help farmers with precision farming. Another example of precision farming at a small scale would be greenhouses. We'll shed some light there as well. Towards the end, we'll see the challenges and a set of probable solutions that can help us overcoming those challenges. Let's start with the current agriculture state of India, right? India, as we know, is economy driven by agriculture. Most of our workforce is directly or indirectly involved in agriculture. If you ask the number, it's more than 50% of India's workforce. India is also blessed with the land. More than 60% of its land is cultivable, spanning millions of hectares. We are also blessed with diverse climate zones, right from the cold environments of north, right, which are very suitable for crops like apples and spices like kesar, to the wetlands of south, which are very suitable for rice. We also have cold and moist climate in north eastern part of India, which is suitable for tea and coffee. Similarly, we have plains of central India, which includes Maharashtra, Madhya Pradesh, which are good for millet, pulses, and cotton. We also have Punjab, Haryana, which are very good at producing wheat. So we are consumer as well as exporter of these crops, right? And we are clocking revenues up to 50 billion with just agriculture. So it's huge, right? And there is still potential. The demand for agriculture and agricultural produce will never be down. Despite such huge importance, right? Currently, the process is still experience or traditional driven. There's no data involved. So let's see why I say that, right? So first of all, the entire process is experience driven. The experience which is being passed by the generations toward down the line, and most of the things rely on that. I don't experience is not a good thing. It's required. We learn from our experiences, but it needs to be backed by the data. These experiences come from our great grandparents, and the conditions that in which they operated were very different from today's conditions. Things like climate change are prominent, and they require a change in these methods. Further, we have very unpredictable weather, right? Climate change is playing a key role here. We see more floods, more droughts, more off-season rains affecting the crops, and farmers are unable to adapt to it. This is more because we take very a reactive approach rather than a proactive approach. We do have data which shows the climate at high level, but the real-time data is the requirement of the hour. Further, the resources, right? Soil and water are the key resources which are used in agriculture. We need to be very careful while using this. These are depleting resources, and real-time monitoring of their health, of their quality and quantity is important because they will have direct impact on the yields. The diseases and pests are always there, right? The climate changes and the fertilizers and the soil quality all can bring up more diseases. So diseases have been evolving. It's not like the diseases are same as what we had 10 years before. But the approaches to handle them, to deal with them, are still the same, right? That's why we are not very data driven here as well. Further, supply chain efficiency, right? This is the post processing of the entire process. There is very poor logistic, majorly connectivity related. There's no transparency. Entire process is driven by a broker system, which do not provide a lot of transparency. Now, when we say we are not data driven, what data or parameters that we can see to collect to become data driven, right? Let's look at such parameters. So first of all, we need to be very aware of our resources. The resources here include the soil, the water, the fertilizers that we use. For example, for soil, we can the data points would be the pH level of the soil, the nutrition, and many more aspects are there. So these can be monitored to optimize the fertilizers that we provide to a certain type of soil, as well as the other resources like water requirement here. Further, we have data from weather. So we do have the data from weather station, but we need to be localized. We already know a part of Nagpur will be drenched in rain, while at the same time the other side of the Nagpur would be pitch dry. So in such situation, we need more localized data right from the small regions rather than the data which is available at district level. And this needs to be continuous. Most of the data that we have is kind of a prediction based, not real time. So that is another data point that can be considered for becoming data driven. And now coming to pest diseases, imaging is the best way to go. We need to see, we need to collect the images of the pest diseases, their impact on the crop, which can be further analyzed, and a action plan can be made for them. So this will directly result into high yields, right? Similar thing applies to the crop growth. Growth of the crop is also important. Imaging the crops at regular interval can help in analyzing the next step, what kind of nutrients it will further require, or some nutrients are being given at excess, or there is a lack of a particular nutrient or resource like water. Irrigation, right? Moisture of the soil plays a big role here. It has direct impact on the key resource, which is water. Monitoring the moisture in soil as well as in atmosphere will surely help reduce the water problems. Air index, right? Air can also impact the crop quality. Studies have shown that it has impact on the photosynthesis that goes into the plant. If there is debris or some kind of material polluting air, they can seriously affect the ability of plant to do photosynthesis and further reduce the yields. That is another data point. Another data point with respect to soil is the erosion. If irrigation not done properly, can erode the top levels of the soil, which are more nutrition filled, because that's where your fertilizers and anything that you do in addition lands. So that is another data point which we can track. Supply chain, it's a very big domain. There is lack of transparency, as I said. We can track the location, so the farmer is never aware where his yield is going, at what price it is being sold. All he knows about the local mandi pricing, right? So a lot of data can be captured from that place, and a data driven approach can be taken here. So these are the data points that can be tracked when we say we want to become a data driven process. Now let's come to the precision or smart agriculture. So basically, this is a process which utilizes the points that we discussed, or the data that we discussed. It is a precision driven, it is a data driven farming approach that uses IoT analytics and automation to optimize the resources. The end goal is to basically get the maximum yield with minimum wastage of resources, like water, soil, as well as the human efforts. One key factor here is that variance with respect to actions. So in general farming, right, if an approach is taken, it is applied to entire farm. For example, if you say I want to enrich the soil with certain fertilizer, the entire soil, entire field will go through it. There's no precision in checking whether a certain section of the farm requires that fertilizer or not. That's the key difference with which precision agriculture brings in. It want to be precise in the actions that it take, as well as the data it collects. The data has to be precise at independent crop level or a section level, rather than normalizing it across the entire field. So that's the key concept here. There are certain aspects of it which are depicted in this diagram, right? GPS and GIS, right? This is a new approach that precision agriculture brings in. So getting the geographical layout of your land will help in analyzing the way we plant the crops. So for example, the land, it can, having understanding of that, can tell you at what distance a particular crop needs to be planted. Further, it can also tell you the low-lying areas of the field which can get flooded, or there are high chances of accumulation of water. So such geographical knowledge of your land can help you in making better decisions. The entire process focuses on automation. They want to eliminate the human errors, as well as the efforts that are required to drive the daily mundane task of agriculture. They want it to be automated. The data collection and the entire process, ideally it should be wireless. That's where the IoT comes into the picture. We'll discuss more about it. VRT, or variable rate technology, is something that we just discussed, right? We don't want to treat every plant, every section of the farm in the same way, because there can be different requirement for different set of parts of your farm or different set of crops. Then the rest of the things involve into tell us about the analytics part of it, and how AI analytics can help us in making informed decisions. Yeah, so these are the general principle on which the precision farming or agriculture works on. Now let's try to understand what IoT is and how it helps in precision farming. So IoT at its base is a simple network of physical devices connected with sensors. They have ability to sense certain parameter. They run specialized software to collect this data as well as relay this data to a more meaningful destination. They also have the ability to exchange the data. They are connected to internet, and I mean in a limited sense. And so yeah, they are basically a network of connected devices. So what do we mean with by the things here, right? The term things. It can be anything which is a source of data. It can be as simple as your fridge, washing machine, or air conditioner. These have already becoming part of your modern home automations, where the data from your fridge, the temperature level, washing machine cycles, air condition, its data is already captured in a central repository, and actions are taken accordingly. Then in industries, you can have pollution sensors which can sense the pollution and take certain actions. Car is one of the best example in this era, right? Something like Tesla cars, right, which are equipped with automation or automatic driving. They are the best example of IoT. Each car acts as a source of data, which captures petabytes of data, the driving patterns of a particular user. All of this is captured, posted into a central repository. And while the data from one car, so anything that a particular car learns in this IoT network is automatically learned by other cars in the network. So that's the power of IoT, which brings in, right? The ability to fetch the data from certain parts of the network, analyze it, and the learnings can be distributed across all the network. So that's where the IoT shines. Then we have temperature, as simple as temperature sensors, moisture sensors. So all of this are part of can be part of IoT or Internet of Things. Some key feature of these systems is connectivity. Of course, the devices needs to communicate and should be able to share their learnings or data. Automation. End goal is automation. It is to reduce the human interventions, to take more informed calls. So that's the automation is the end goal. Data collection, yeah, each device needs to be a data generator, otherwise there's no sense of adding it. Either a data generation or a sync, where the data will finally land and analytics will be run. It also enables remote control based on the monitoring and the data it provides. As it is Internet of Things, it is connected to internet. It allows us to remotely control the actions of these devices. Generally, the entire architecture of IoTs can be thought of like a four-layer approach. At the bottom, you have physical sensors. They are basically small electronic circuits who generate very raw data. There's no tagging, there is no parameterization to it. They simply generate the data and pass it to a bit more sophisticated devices. Example would be Raspberry Pi, right? They are very close to the sensor. They fetch the data, raw data, may perform certain level of computation, cleaning up of data, and then they pass it to the more capable entities in the network. Network is the backbone, right? The data collected and whatever the insights that we have should be shareable over the network. As it is connected to the internet, half of the things are taken care by already existing infrastructure. However, while implementing the devices in your particular farm or particular situation, we may need to set up a local LAN. Then we have a data processing layer, which usually sits in cloud. That's the sync of everything. That's where the actual analytics takes place. Here we get the information from the raw data. Finally, the application layer. This is where the whatever the analytics AI that we have done is finally presented to the end user. Application layer can be as simple as a Android app in your phone or a iOS app in your phone. It will usually have the dashboards, insights that the data processing layer has come up with, so that the farmer or anyone who is part of IoT can make a informed decision. Let's look at a sample architecture, right? In case of agriculture, right, we can have sensors like temperature, humidity, soil, rain, airflow, air quality sensors. As I said, these are attached to edge devices like Raspberry Pi. Uh, the Raspberry Pi actually, this device has changed the entire landscape of IoT. Something which came up as a hobby project, or a way for nerds to come up with small projects in their basement, changed the way IoT works. So these devices, I'll discuss more about them. These devices basically capture the data from the sensors and share it over the internet. So they have a valid operating system like Linux running on them. They have the capacity to connect to the internet, something which OS provides them. They communicate with the rest of the network or cloud via HTTP requests and responses. The data then lands into the cloud. Firebase is just an example. We'll discuss more about the cloud computing in upcoming slides. Now, certain decisions are taken based on the computing which happens in cloud, and again a response come back to the edge device, which is Raspberry Pi. Now that response is converted to an action. For example, here if you see, there might be a water pump controlling the irrigation system of your farm. So such actions can be controlled again by Raspberry Pi locally. So that's the general architecture. The key components, if you ask me here, is are the edge devices along with their sensors. Then there is the cloud infrastructure, which acts as a sink. A sub part of cloud infrastructure would be the AIML or analytics modules, which will be continuously analyzing this data. And further, the dashboarding, basically the user needs to be informed about everything. And whenever required, our intervention can be taken up. So that's the general. These are the general components of a precision farming architecture. Now let's look at these independent components a bit more. So edge computing, as I said, right, these are the devices that enable IoT. These are the devices that are at the end of the network. They are also called as edges. They have capability to communicate, to connect with outer world. Majorly, these devices run a very light version of Linux operating system. The operating system provides the ability for connection management, data storage, ability to sense data through the sensors, as well as the relay the action to the next set of actions or the actions identified. In terms of processing power, they are very much limited. Yeah, we cannot put heavy processing on them. So majorly what happens here is the data pre-processing. The raw data can be parameterized, tagged with proper tags, and formatted into particular format like XML, JSON, protobuf, and it does its part and then relays it to the cloud. That's the major thing here. However, with the increasing power of the chips, right? There are platforms like NVIDIA Jetson Nano, which are able to host small, very specific AI models, which can do some kind of analytics right then and there itself. Yeah, so that's pretty much about the edge computing. So I mean, it's okay to consider sensor and edge computing as one entity, as an edge of the entire network. Now let's look at the next hop in the system, which is the cloud computing. So these edge devices, right? The key here is to monitor the environment or whatever the parameters we discuss continuously. That means each edge is capable of developing or generating terabytes of data in one go, right? Over the period of time, they can accumulate huge amount of raw data. Some pre-processing might happen at edge, but again, we need a common sink where everything can come together, processed, stored in a structured way, instead of storing it raw data, store it in very structured way, optimized way, and then this data can be fed into the other microservices which are based on AI ML analytics. There the actual decision making or analytics can happen. So cloud is that layer which acts as a central repository of the IoT network, and it can be accessed by anyone in the network. The key technologies here are big data technologies like Kafka or Spark for inline processing of the data. They make sure that we are able to scale according to the ages, the data which comes from the ages. These cloud also help us in scaling up easily. So we there's no importance given to the infrastructure as such. So the end user does not need to know much about infrastructure. For example, Amazon EC3 instance, right? Depending on the load it is coming to it, it can scale automatically. So that's another advantage or key technologies used, automatic scaling. It also provides a sort of authentication to the data, as well as data security for the data which is at rest. Storage is another important service that cloud provides. The data can be stored in S3 buckets or blob stores of Google and Microsoft. Finally, the ready-made microservices for performing AI analytics on the data that we have collected. So seeing the growth in the IoT, right? Each individual cloud vendor came up with their own IoT solutions. So what they did basically is combine the key technologies that we discussed and provided a solution as simple as that, calling an API. So you call an API for authentication, storing the data, pushing it to certain analytics, and rest everything behind the scenes will be taken care. Each, as I said, right, each one came up with their own platform. AWS Core is something which is very popular. It is very reliable, but others are also gaining the traction. The last part, right? The last part to all of this is AI and machine learning. So a lot of discussion happens on what kind of analytics, whether AI or ML makes sense in these situations or not. So that's where we'll discuss in each of these things in bit depth. So once the data is collected, it goes to sort of pre-processing. The entire data needs to be labeled. By labeling, I means a sort of description needs to be added to each raw stream of data. And the first step is to perform analytics. Analytics is basically finding patterns and trends in the existing data. It can show you the hidden meaning into the data. It helps you to understand what has happened in the past and what is happening currently. So the data that is collected is from the past, and the incoming stream is basically what is happening now. So these two things can be fed and got into, and what we can get is the trends or patterns or insights. So analytics is very deterministic in nature, whereas AI ML are very probabilistic or dynamic in nature. Analytics is morely based on heuristics. It is backed by the numbers. There's no thinking to it. So the major differentiation here is the ability to think and predict. That's where the analytics can fails. So by analytics we can ask questions like, what was the best selling crop this year, right? What was, if you see, like most of the questions would be starting with was, right? It can predict, it can tell you what has happened. So another would be as simple as, what was the price of this crop in this year? What was the selling crop of a particular year? So these are very static. This is all very static information which can be accessed. Analytics is very good at presenting data. It utilizes all sort of charts, graphs, and whatnot to present this data in a proper way, which is very easy to understand. So that's all about analytics. Again, the analytics in precision farming, analytics is used to mostly to create the dashboarding part of it. It tells you how much the resources were used, how much certain pesticide or certain things were used. It can also come up with charts stating different parameters, what were their levels at certain time in the year, right? Or what are the current levels. So here, one thing you will always see that analytics cannot fuel the automation. It can fuel the uh, data-driven decisions, but that decision has to be made by someone, a human or a farmer who has the domain knowledge. So that's a key thing with respect to analytics. Now let's move on to machine learning. So ML is kind of a subset of AI. It's not very distinct from AI. So it involves training the computer. That's the key word here, right? Training, which is what differentiates ML from analytics. It is basically training the devices or computers or software components to learn from the data that we make, and this learning can be used to make predictions. So everything around us is based on learning on prediction. When someone throws a ball towards me, I basically predict its trajectory, where it will land and where my hands to be should be. So that's the key difference that ML can bring in. What analytics can bring is what time that the ball was thrown, where it landed, but machine learning can track the trajectory of that ball. A good example, good question here would be, which crop can be bestseller? The can indicates the future, right? So it can predict things. It can predict things as complex as what crop, considering the current weather in my location as well as the past record of market, can be best suitable for this particular season of the crop. So if you see here, multiple queries were combined, and this requires thinking or ability to think or predict. So that's the key difference which ML brings in into this pipeline. Again, it's a subpart. And finally, AI, right? AI is the superset of all of these things. It combines all of these technologies and it adds action to the prediction. So a simple example would be your phones, right? You have Google Assistants, you have Siri. You can ask certain things, and based on its learning, it can take action. It can reduce your screen brightness. It can search some particular settings in your phone. So AI would be majorly driven. I mean, the precision farming would majorly rely on AI, the ability to predict and perform tasks which requires intelligence like human, right? It will include everything from automating irrigation systems to the ability to automate the fertilization, and make precision decision based on the locality of the data. Example here would be a smart farming system that uses drone sensor and AI to monitor every aspect of your farm, monitor crop health, predict the weathers as well, predict the growth of the crop, predict the future demand of the resources. That is kind of important, right? uh, Predicting the demand of fertilizers, we can help farmers stack things in advance. They don't need, the approach will completely shift from being a reactive approach to a proactive approach. Then yeah, a bunch of other things like irrigation and everything can be automated. So these are the three key things which are kind of confused, but each level brings us its own intelligence. Yeah, so that's the third part of the wheel, right? First being the sensors or the physical devices. Second being the cloud, which provides us the single source of data collection. And lastly, what do we do with that data, driven by AI, ML, and analytics? So that's how the architecture spans. Most of the systems are similar. And each of the cloud provider has come up with all these microservices, which are readily available. Now let's look at the outcomes of a Tamil Nadu precision farming project that government took up. So this experimentation had more than 400 hectares of land. The project span was 3 years. Good amount of budget of 7.2 CR was allocated. 400 farmers benefited from this entire initiative. So the initiative was again something similar. It was more focused on common yields like brinjal and tomato. These are short duration crops and are highly affected by the weather conditions. Their demand also is constant, and in order to be a distributor or provider of such crops, you need to show the consistency in the yields. Right. That's where the precision farming helped. So they started monitoring each of these pads. They divided the entire land into small pads and started monitoring each and every aspects of these crops. Special devices and IoT infrastructure was established. I'm not sure which cloud vendor they used, but whatever we discussed, right? They established the three aspects: the sensors, cloud, and the analytics part of it. With that, right, the yield was increased by significantly by 30 to 200% across various crops. Tomatoes yield was increased by 80%, almost doubled. Brinjal was increased by 34%. Obviously, the increase in the yields will directly result in increase in the profit margin, and that's what the need of the hour is. So this was a quite successful experiment, which showed the potential of precision farming has over the traditional farming methods. Another very good example of precision farming at a lower scale is greenhouse. I think most of you have seen this already, right? Greenhouses are specially developed covered farms where every aspect of farming is monitored and controlled. Most of these things are automated. There is very minimum intervention. Idea is to use every resource in a precise way. It also focuses on reusing the outcomes or wastage in a proper way. So the outcomes. So for example, whatever the raw material we get after selling the mangoes and all, any crop, right? Those are converted into organic compost and things like that. So here every aspect, right, from the temperature, the humidity, the temperature of soil, temperature of plant, the amount of water it given. So in some cases there is no soil also. Directly the plants grow into the water itself. Again, that water needs to be monitored for pH levels, nutritions. Each and every aspect of it is monitored. All of this data is again processed, is again forwarded to the edge computers. As a more, it can be more sophisticated devices, may not be a Raspberry Pi level device every time. Then the data is then relayed to a cloud over the network, which again performs the last subpart, which is AI, ML, and analytics on that data. The actions are computed and relayed back to the edge computers, which directs the air conditioning, the intake of flow, or any aspects of the agriculture can be controlled with that. So this way of farming is gaining traction in India. There are a lot of peoples who are going who are experimenting with this and getting good results. uh, Currently, because of the scale and because of the investment, these things are mostly confined to small crops like tomatoes, cabbage, vegetables mostly, and uh, uh, and some seasonal crops which otherwise cannot be grown in a particular condition. Another example would be your cultivation of kesar, right? It is something which can be cultivated only in cold environments. So maintaining that cold environment suitable precisely for kesar is something what precision farming along with the technology can achieve. And people have already demonstrated it and made a successful or profitable business out of it by running it in a small container. Uh, yeah, so such kind of ventures are otherwise won't be possible without use of technology, IoT, and precision farming. Right. Let's try to understand more on the challenges, right? Challenges are there are a lot of challenges, especially with the infrastructure. I don't think technology as such is a challenge. We are handling more complicated tasks than agriculture. We have banking system which handle hundred and thousands of transactions automatically on a daily basis. So technology is not a challenge uh, in general, but the infrastructure required to deploy that technology is the challenge. Uh, First of all, the resources, right? Farmers are not that resourceful. They cannot simply go and buy the devices. Even if they buy the edge computers, which are not that costly, they need infrastructure or cloud support to collect the data and analyze for them. That is again, the cloud computing is kind of costly for enterprises itself, let alone the farmers, right? So that's the major hurdle here. And this cloud infrastructure, right, it has to be centralized. So I remember from yesterday's session, someone pointed out that how do you connect the dots, right? Yeah, I think that was a very good question around it. So connecting dots require a central infrastructure. Uh, so there needs to be a central repository which will collect the data from all the stakeholders in the agriculture process. That would involve people like farmers, right? The real data from bazaars or mandis where the actual yields are sold. All of that data needs to be collected at a central place, and building that data center is the real challenge in precision farming. Locally, people have proven it, but that requires some sort of good amount of investment over a period of time. Yes, precision farming will definitely give you good revenue compared to the traditional ways. But yeah, lack of the revenue is would be a major problem to set up such central infrastructure. So unless and until I think a farmer can ask a question like, which crop should I cultivate considering this kind of situation at this duration of at this period of the year, I don't think this technology will be helpful at all. So for that, we need to connect the dots, and only way to is to have a national level, I would say, not even district or some or a local level. Instead, we need a national level infrastructure to collect all this data. Second thing is in the standardization issue. Uh, IoTs there won't be a single IoT network, right? It can be as simple as each farm being its own IoT or Internet of Things, right? Now, how assuming that there exists a central repository of the data which is capable of processing it and giving the insights, there needs to be standardization of the entire process, right from the format in which the data will be sent to the centralized systems, right? Will it be in JSON, XML, protobuf? Everything needs to be standardized. The outcomes, the parameters at which a certain data point would be measured, or the intensity of the actions. All of this needs to be measured, and a standardization needs to be there. Otherwise, it would become really impossible to handle the data from so many heterogeneous sources. Yeah, I think we discussed this already, right? Initial cost is high. Again, the cost of maintenance would also be high. I think as the technology grow, right, this will come down for sure. We have seen this already, right from the televisions which costed some lakhs of rupees, now can be bought in a couple of thousands, right? So as the technology and adoption grows, the initial cost will definitely go down. At the same time, maintenance will also come down. uh, Connectivity, right? This is another important thing. Without connectivity, I think IoT will not be able to survive. There has to be connectivity. Remote areas needs to be connected wirelessly with 5G, 4G, and a capable data network would be required. Lack of technical expertise. So yeah, this is something which the economics is struggling with, right? The farmers or the any stakeholder in this process, right? They don't understand how these technologies work. Most of the time I hear that this data is collected against them. They don't know how this data will be utilized. So they lack the technical knowledge of around all these technologies, and that's where they keep themselves away from any such experiments. Then power supply. Yeah, the entire precision farming depends on power supply, right? We have energy constraint, but I think this again, India is very lucky in terms of solar. The amount of solar energy it receives, this can also be tackled. Already, people have got subsidies for running the solar-based motors. The government is very proactive in this, so this may be solved. But this can have a very significant impact. For example, I was talking about greenhouse, right? A single half an hour or 20 minutes of outage can seriously damage your crops. So that is another challenge that we have. Finally, the cybersecurity and the data privacy. If you have a agriculture process which is being driven solely by technology, high chances are there that you will be attacked, right? Because data is the gold of this century, and any attack can deviate the outcomes. Instead of giving fertilizer, the attack may ask you to give more water. That will hinder the entire economy. So that is a concern, but I think we are very good in these terms. We have the encryption algorithms, correct way, network gateways, API gateways to protect the source and sync of the data. Again, we do thousands, crores of transaction, money related transaction, and we are kind of protected from most of the attacks. So I don't think this is a major risk. Only concern is the privacy of data at the edges, or the physical level. So these are the some technological challenges that we have today. Now this farming is is kind of a social concept, right? It cannot be limited to use of technology. A lot depends on the mindset of the people using these technologies and how they adapt to it. In general, there is always a resistance to adapting to the new technologies. That is more because the lack of awareness. They are basically scared to adapt to something new, because a loss of crops can affect more to a farmer, right? It's kind of their livelihood, so they restrain themselves from doing any sort of experiments with respect to these things. But yeah, here we'll discuss more on the how to tackle this. But yeah, social impacts are play a major role here. We have already talked about the digital literacy, right? The resistance comes from lack of awareness. Then there comes the policy and bureaucratics, the way government handle these things, right? The policies have gaps. The implementations are very slow. That takes away the faith from the system, and corruption again, it's still prevalent in most of the cases. Further, see the amount of money that you invest in such technologies are not suitable for small farmlands, right? In major countries like US and all, right, the farmlands are always big pieces of land. If not, they go with a cooperative farming model, where a big patch of farmland, having multiple farmers, is cultivated in cooperation with each other, rather than each working independently on their land. This makes the entire process a bit more efficient, and enabling IoT and precision farming for such long patches is better in terms of revenue, in terms of yields and everything. But again, the social impact and the mindset comes into the play, right? I don't think a lot of people go along with each other when such thing comes. They're always afraid of how the profits will be shared. If there are losses, there might be finger pointing or blaming. So these things are still, still needs to be adapted, so that we enable IoT based farming or precision farming in big chunks of land, rather than applying it to small chunk of land. So these are the major social challenges. Now, coming to the solutions for these things, right? These are my insights. So building infrastructure, there's no way around that. Unless and until there is infrastructure support by government, people are not going to experiment. Tamil Nadu government led this by adopting and taking the by investing in the technology. uh, Schemes as simple as investment by government. The government can invest in infrastructure and can be a partner in the yield. The profits can be shared with the government. That's how the trust which is required to bring in these new technologies can come in. Government needs to be an active partner rather than a sleeping partner. Subsidies, yeah, subsidies on technology adoption. I think government is again doing a lot here, but many times this subsidy goes into loan waiving and other subsidies which might save them temporarily, which might provide some relief temporarily, but in long run, it won't help, right? Unless and until this entire process becomes data driven, more autonomous, the subsidies won't help. The same set of mistakes, if we keep on repeating, there won't be new yields. So that's where the government needs to think through. Farmer training and partnerships. So reaching out to farmers, making them aware, making them connected, showcasing these advances, yeah, creating seminars by the people who have actually implemented and gained good gains from this process. All of such training programs needs to be run by government. Public-private partnership will be a key to unlock the infrastructure. Without that, I don't think it's possible. We are, I think, we are good here to some extent. Geo companies like Geo, Airtel are all have penetrated almost all of the India. Some parts still may be still there, but to start with, we already have the infra, basic level of infra with respect to communication available. Further, this private-public partnership may be utilized to set up clouds, right? Asking government to set up a cloud from scratch, or the infrastructure required from scratch, is not feasible. There has to be a partnership with some other private entities like Amazon, Microsoft, Google. So there has to be a public-private partnership to enable this entire process. Finally, the data and the data has to be collected locally, localized, as well as it has to be centralized. Um, as I said, right, we are yet to adapt the cooperative farming, so these solutions needs to be adapted for small scale farmers. Now let's look at, it's not like government is not doing anything. They are doing their best to support these schemes and try to bring in more and more people into this. So majorly, if you see, they have come up with a smart precision horticulture program. Horticulture is basically a science of cultivating the crop, making it more efficient. So they help in integrating the advanced technologies like IoT. Drones are still a kind of far-fetched goals, but still they can help. So idea is to boost the entire efficiency of cultivating the crops. More than 6,000 crores are allocated to implement these schemes. It targets more than 50,000 acres, and the aim is to go from, I mean, the process will start from 2024, and aim is to bring more people into precision farming by 2030. So yeah, this is a good initiative, and these things are required to boost productivity. Uh, Further, we also have funding provided by government. This funding may be a completely free funding, or loans to the farmer organization or private entities which actually want to build and do good in this space. So they provide financial support to the infrastructure project related to smart and precision agriculture. They also offer loans with very bare minimum interest of 3%. Now this can be given to individual farmers, then organizations or any societies which help in building the backend for this entire thing. So yeah, funds are required, and I think government is helping out there as well. Only I think, as I discussed, right, the ease of getting this fund is something which needs to be looked into. The policies which drive these funds needs to be more customer or farmer friendly. Um, then only these funds will be utilized in proper way. Yeah. So finally, the government have deployed farming centers, precision farming centers called at PFDCs. These centers are responsible for experimenting with the technology, and these centers can also be utilized to gain knowledge about these technologies. They test, adapt new farming technologies to the local conditions. Yeah, again, the local condition, having the knowledge of local conditions is very important in this situation. More than 22 PFDCs are set up across the India. Majorly, these are being funded and researched by IITs, NITs, agricultural universities, and more educational institutes in India. However, I mean these things needs to reach to the farmers. Running these centers alone would not help. The awareness that these centers exist is more important, I think. That was more focused on government, right? I see a lot of private sector jumping into jumping into this space. And so whenever a private companies enters, right, it's sure that there is a huge scope. Unless and until they see the scope, they won't enter. But it's good that we are seeing more and more startups trying to enter this field. Many of them, a couple of them I have listed here. Fasal is one of the startups working here. They all of these are very well funded startups. They want to bring AI powered IoT platforms, providing again the real time crop advisory, optimization, irrigation. So they are kind of pitching into the central repositories that we need to build this systems. They are planning to have such kind of central repositories which can help collect data from one, learn from one data set, and that learnings can be passed across all the people. Now they actually they are the ones who provide the infrastructure. That means the IoT devices, cloud, and everything is taken care by them. I'm not sure how they generate the revenue. Most likely, they have some sort of percentage out of the revenue from the farmers. Again, Cropin, another cloud and AI based startup. Pixel is an interesting one. So they are exploring the less export GIS system or the satellite imagery systems to analyze the landscape of farms, basically getting the geographical knowledge about the land. This makes more sense at for the farms which have huge demographics. They can help you to analyze soil health just by pictures of the image satellites. They are able to analyze the soil, the crop condition, environmental changes. So this is an interesting startup, and they're exploring a niche into this field. Then we have RF unmanned systems. So drone technology is not at all popular in India. Even though we have systems like IoT and edge sensing available, but I have not personally seen drone monitoring or involvement of drones into this entire process, and that's where RO systems is jumping into. They want to make this entire process very with minimum cost. They provide, like, unlike Pixel, which will take help of satellites. They want to be little bit closer to the terrain. They'll utilize the drone technology to actually capture the agriculture land and collect the data around it, and help us, basically surveying the land, and help us in building the more knowledgeable decisions on farming. Then again, Internal Ops is again one other startup which again focuses on AI driven. They focus more on the quality aspects of the food based on the data set that they use is the image of the fruits, crops. They assess the pesticides. They assess the quality and variations in the quality. So that is another very good startup that is exploring this area. So yeah, we see good interest by private sector into agriculture that will help us bring back the youth into the system, uh, which is kind of living away currently. Towards the conclusion, right? This farming is a technique which has been passed down since centuries. It is the backbone. One cannot simply ignore it, especially India. If it wants to move from developing to developed, we need to focus more on data-driven farming. The evolution started with the use of machineries, pesticides, and other things in somewhere around in 2000. And since then, there has no significant enhancement in the way we do farming. We do have data, but the data does not make sense. The farmer is always confused about the next step. He does not have a central way to monitor, to predict, and to analyze the current conditions. So that's where we want to move from a more intuition or experience based farming to a more insightful data driven farming. The future would be a large scale IoT network which will connect thousands lakhs of farmers together, where the data from each farm would be analyzed, learned, and the insights would be passed across across the country. Now, this one more point I think I missed is this is not limited to agriculture, to crops, even the cattle's, right? Cows, the production, milk production, their environment, their living, that can also be enhanced. That poultry income can also be enhanced with a data-driven approach. So that's the direction I think India should lead into. And as I showed, right, in interest from private sector will help in driving this entire change. I've added a couple of resources which I referred. Uh, yeah, yeah. So that's pretty much about the precision farming and its scope in India. Thanks.
Thank you so much, sir. Questions can be asked, if any, from the audience side.
Hi, good evening. This is a very good initiative for the farmers. So this project will actually take the farming at the next level. So this project, whether this project will be the closed-ended or open-ended, like is there any framework, architecture, or any framework design, and will it be make as an open source for usage of all these private sectors or
Exactly.
stakeholders?
Yeah. Right. Yeah, sir. I think that's an excellent question, right? So in the challenges, I discussed this. There is a lack of standardization, and I'm definitely sure we need an open framework for that. Open source framework which describe each and every step in this entire process, and which will basically something which should be driven by governments, not local, not even nationalized. That should be at international level, and I don't think we have it as of now, but that's where we should head. That's where we are lacking. I hope I address your concern.
Yes, thanks.
Yeah, I mean, it will cover every aspect, right? From the data, the type it has collected, the processing which happens, the models, AI models that are used, the sampling at which the data is collected. All of these aspects need certain amount of standardization, and open source is the best way to go. You need to be open source about this architecture so that not just us, anyone entering into this field can utilize it.
Yes, using the open source, everyone can contribute to that project. Actually,
Exactly.
we have the domain knowledge of these
Exactly.
areas.
Right.
Yeah, correct. Thanks.
I think Ishraq Ahmed sir has a question. He's raised his hand. Ishraq sir? Yes. Plaban sir, please continue.
Sir, good evening. It's a really nice presentation. I would
Thanks.
like to know about, do you have any company reference who can guide us to develop or give guidance related to IoT hardwares?
Oh, IoT hardwares.
Yes.
I don't have any such reference handy, but I can certainly look into it. So basically, you want to know which IoT device would be, or which IoT devices would be suitable for which use cases, something like that.
Yes, sir. Sir, because right now we are proceeding for a AI-based coffee farming and strawberry farming. Okay, sir.
Okay,
In
excellent.
Odisha, Koraput.
Okay,
So right now, one of my hindrances is we are communicating with NIT to develop the that is weather stations locally, so that will
right,
be cheaper for the farmers. And
exactly.
yes, they will provide us the IoT testing kit also. But my concern is that because any private company who is producing or manufacturing these localized IoT products, so that we can communicate with them, we can get the technical knowledge about the product, and we will
Right.
transfer it to the technical colleges. That is my one concern. And second is related to awareness. Okay, sir.
Yeah,
In which level we have to start the awareness? That is from school level, or that is from college level, or that is we have to, like, at present condition, first we have to train the farmers what exactly the AI is. AI based farming is different thing, but what exactly the AI is. Okay, sir.
uh,
This is a purely 20 to 25 years project, right, sir? So
yeah,
from today itself, on which level we have to focus? That is from 10th, that is 10 class 8 or class 10 students, or class 12 students, or diploma or degree students, from the educational point of view. And for the
correct.
farmers, for the farmers, we have to start it immediately. So can you please guide on that
Yeah,
related?
sure. So basically awareness, as you said, right, can be distributed among the workforce, which will in future participate into such vendors. And that's where introducing such subjects, I think, at somewhere at eight level or eight ninth level, where they can explore these things. The moment you reach 10th, 11th, 12th, you are already pressured by all the competitive things that are already there, right? JEE mains, whatnot. So some buffer, if we can take some buffer and put it in something like 8 standard, where they have the buffer to actually think about these things and to explore these things, would be excellent. That's the part of the future generation. Now coming to the farmers, right? I think working this at tehsil level or gram panchayat level is the best way to go.
Yes, sir.
Uh, we have the bodies which dwell down to the tehsil level, not even tehsil, I think ward levels also, right? We have ward members. So this effort needs to be taken at that place. Uh, I think we already have the infrastructure and the techniques required to communicate this. Only thing is that initiative needs to be taken.
Yes,
And
sir.
moreover, this has to be a example. Government has to lead this with an example. You cannot simply tell someone to use and leave it there. Government needs to take some part of the land in each of these small villages or gram panchayats, and show them the effect of this, how efficient you can be with this. And
Yes.
awareness along with example based leading is the best way to go,
Yes, sir. Sir,
I hope.
actually, as for the first, we are experiencing that hindrances
Yeah,
related to localized IoT hardware. That is the really a big issue for us.
correct. Yeah, I understand. Yeah, production. Yeah, that's what India is, more service driven economy rather than production based, right? That is, again, we need to think how to localize and reduce the margins.
Sir, if you have any reference, please let me
Sure.
know.
Sure, sir. I'll pass on to Rashmi ma'am or Nasruddin sir if I find anything important.
Okay. Thank you, sir. Thank you.
Thank you.
Paresh sir, so from which location you belongs?
Sir, I belongs to Odisha, Koraput.
Okay, okay. So I heard some from the Nasik area, from the Maharashtra. They are having some startups, and those startups are having like this such IoT devices, and they are working with the farmers, like the prediction of the diseases and all this stuff.
Sir, this will be helpful for us if you will provide us the contact details so that I will communicate with them.
Okay, sir. Thanks. I will provide that. If possible, I will give their contact details if I get soon.
Okay, sir. Thank you, sir. Thank you.
Kiran sir, there is my another question.
Yeah, sure, sir. Go ahead.
Sorry, I'm only the asking questions.
No problem, no problem. This has to be an interactive session. Yeah,
Mhm.
go ahead, sir.
So, like the devices, right?
Yeah.
So, are there any good manufacturers like we are developing like that? And another question is that so there are so many startups that are going on, and even the central level, the farm stack is also going on, agri stack, right?
Yeah, I agree, sir. Yeah.
So how we can actually collaborate? Like yesterday I asked how we can connect those points again, connecting the dots.
Yeah, it has to be taken up by government, sir. There's no other entity which connects every aspect apart from government. They has to bring the standardization. Otherwise, every part or every startup will come up with their own ways to do things.
Mhm.
And I would leave the private sector from it because their motive would be very different, right? They'll be
Yes.
more money minded rather than helping out the farmers. So unless and until it's the government who is connected to mandis, who is connected to technologies, who is connected to
Mhm.
individual farmers, who has the capability to go drill down to the end of the pipeline and fetch the data, I don't see any other entity which fits at this central place. It's a huge task, but can only be carried out by a centralized government. A public-private partnership would be a best thing to do. Uh, the service-based companies, right? Infosys, TCS, they do provide IoT-based solutions.
Mhm.
So a collaboration of the network of government along with the technology of these companies is the best way to go, I feel.
Yes. Thank you.
Good evening, sir.
Good
I'm
evening.
Pinakapani from Bangalore. Okay, I have two simple questions, sir. Okay,
Yeah.
regarding what are the research gaps in this domain for soil analysis and improving the crop yield, sir? Could you please give some insights over it?
I think there is ample of research being done at this point. The main challenge is making this research reach to the ground level. There has been a huge amount of research being done in these areas. With respect to, I think it's more about the providing this research or making the outcomes of this research reach to the farmers. I don't see a major gap. If you simply open a tab and search how to improve crops, you'll see hundreds of papers citing things. But I think real point is how we make this research reach to the end, to the leaves of the system.
Yes, sir. Understood. That is our next question for me. Like,
Yeah,
how to reach to the farmers with respect to the precision farming awareness in increasing their productivity levels, or even to know the future crops to be, to future crops, which are all the crops that they can sow in their fields. Definitely,
uh,
tremendous theoretical research is going on, but to
correct,
reach to the ultimate, customers or stakeholders like farmers, they're not
correct.
getting it. How do we reach it?
So there is another mindset which I talked about, right? It's surprising that we have agriculture centers at tehsil level where as simple as that. So I also own a farm, right? Till some time I was not aware of the agriculture center which is in Nagpur, near Amravati Road. So they provide services like free services, like take your soils, go to them, and they'll analyze and tell you everything. But you need to be aware of these services. Again, it has to go till the government level, and they have to make them aware. I see this infrastructure, right? Things are in places, but they are disconnected. There is clearly a communication gap, which is there, which needs to be filled up again by reaching. So another things which are driven is, there are agriculture communities of farmers, right? Just like we have communities, I don't remember that specific name, but just like we, for professionals, we have a community like LinkedIn, right? There are efforts, or there are startups working. I forgot the name. I can come back with that. But there are farming communities as well. There they provide all such information. They pass on to the research, to the end users, which are farmers. So more adoption of farmers into this will help. And also the involvement of youth in the house, right? If the youth of the house is involved into these systems, the adoption of technology and the ability to join such forums will be high. I hope I answered
Yes, sir.
the question.
I got it, sir. Thank you. And finally, one question, sir. Like, for doing research, like, how do we collect the real-time data sets for doing research activities on this? Because we can get it from the government institutions, like even government universities
Correct.
like GKVK in Bangalore, or else even other government institutions. Even ICAR also is providing such data.
Yes,
Like,
ICAR also.
yes, but how far it is reliable? Because even I also came to know that the ICAR data will also be that much not accurate to take our experimentals to be proceed further. How far it will be reliable? Can you just
Reliability is a difficult thing to comment on. uh, so basically, yeah, it's difficult to check the reliability until and unless we introduce another technology called blockchain into it, right? I hope so blockchain is a technology which makes sure data from the source is never changed till the destination. It's basically consider it as a bookkeeping way of recording the data. You have a very huge registered, which is distributed in nature. When I say distributed, a same set of data set will be available on millions of devices across the network. Now, once a certain information is entered into it, it's guaranteed that it will not change till the source of it. So if the sensors or whatever the data sources these guys are using, right? If they adopt to blockchain, then I think this problem can also be solved. But until then, it's really difficult to say if the data is synthetic or actually coming from the live sensors.
Okay. Thank you so much, sir. It was a nice presentation.
Thank you.
Thank you, sir.
I would like to add this point as well, because every startup is starting giving the information to farmers, but they are at the baby level. So unless and until they grow far more, and they actually their model will be perfect, and when they get the whole data or the most of the data, then their model will be perfect and they can provide the perfect decisions. Now, currently, the decisions may not be right or at that level. So you can use and take our decisions based on that those information.
Right.
Yeah.
More informed decision rather than blindly believing on them.
Yes. Thank you, sir.
Yeah, thanks for adding.
Sorry to interrupting in between.
No problem, sir. That was insightful. Thank you.
Plaban sir, any more questions from your side, sir?
Yes, ma'am. Sir, what technology we have to use for initial testing procedures? Shall we go with the Raspberry Pi, or we go with the LoRa system? Which will be better, sir?
Sir, I feel Raspberry Pi has matured a lot. The Raspberry Pi. So the thing is, Raspberry Pi came out as a toy to play, right? it was a toy for highly intelligent people who were very keen into robotics and all. So the community which drives the development of Raspberry Pi is very good. I mean, they're a bunch of intelligent people, and you'll get all the help possible about Raspberry Pi online. I
So
have
commercially
personally,
viable, which will be commercially viable, sir?
sir, I am not sure about the pricing as of now. It has been a while I have bought one, but definitely in long term, when the issues arise or something goes wrong, right? I still feel in terms of availability also, the Raspberry Pi would be more available compared to anything else. Arduino is also another good option.
Okay.
Uh, but I have seen the people using in tier 2, tier 3 cities, basically using Raspberry Pi in tier 2, tier 3 cities in colleges. So that's the penetration of Raspberry Pi, and I'm damn sure it is backed by a very good community online. So definitely, if I want to get into IoT, a Raspberry Pi would be a very good option.
Sir, one point is just coming to my mind just right
Yeah,
now.
yeah,
During that wireless transmission, because we are testing our project at tribal and mountain area, and this is
okay.
in point of that is safety. Is there possibility that anyone can hack that and use that for their own benefits? Like,
Yes, there are high possibilities. For
okay.
that, we need to encrypt the data at rest as well as on wire. So I am not sure which technologies you are using to, or which communication method you are using. So if you ask me, a simple TCP/IP data over TCP/IP connection can be encrypted with SSL. That is a good way to go. SSL will ensure that the data is not trapped in between.
Okay, sir.
And on platform, I think, see, Linux also, the Raspberry Pi devices, right? They run operating systems like Linux, where you can implement firewalls. So you know the address where the data will go or the data will come, right?
Okay, sir.
And you
Yes.
only allow the traffic from those IP addresses only. So that's how the firewall works. Disable
Okay.
any, and I mean, the way hackers reach to these devices is via services like Telnet, SSH. So disabling such services which are not being used on that device will definitely help. Encrypting the data when you send it, that will help. Implement a firewall so that only the known entities communicate with you would also help.
Okay, sir. Because my concern is that we are going to work in Knoxless area.
Yeah,
Okay,
yeah,
sir.
correct. Yeah, yeah,
So,
that's
so
a very valid
that is
concern.
my concern. So that tomorrow I will discuss this point with my senior.
Sure, sure, sure.
Okay. Okay. Thank you, sir.
Yes, any more questions? So that was quite an interactive session. Thank you, Kiran sir. You
you.
have briefly, you have the use of IoT for smartly controlling the yield. For that was quite briefly explained, and how precise monitoring can increase the growth of crops was again briefly elaborated with the help of case studies. Thank you so much for your valuable time enhancing our knowledge in the field of smart agriculture. And we are also thankful to Dr. Rashmi Bade for her contribution for inviting such eminent speakers for the program. Thank you, ma'am. And to our interactive audience as well, to the participants, it was quite an interactive session. Your doubts are clearing it is enhancing our informations as well. So thank you so much, everyone. Thank you so much, Kiran sir.
Thank you, everyone.
It was a very fabulous session
Thank you. Thank you, ma'am.
Thank you, ma'am. Thank you, everyone.
and quite an informative one. So we will be just waiting for 5 to 10 minutes for our next speaker to join, and we'll be resuming it back after 10 minutes. Thank you so much, everyone.
Thank you.